So starting with the well status workflow, Alana has the ability to store several data, several tables in its Postgres structure. So one of those tables, one of those databases, kind of to store data, is focused on the well status. Whenever we're developing a field project, whenever we're developing some workflows with the data of a field, of a couple of wells and things like that, it's important for us to have the status of those wells. So we developed in the AlanaPy. No, I forgot. We first need to upgrade the AlanaPy script. Okay, so give me just 1 second. We're going to upgrade it using this terminal. It's sudo noise pip install upgrade AlanaPy. With these simple commands, we're going to upgrade the AlanaPy script. There you go. We are currently on the 0.16 version. It's going to install the repositories needed, and it's successfully built the AlanaPy. Most likely, there you go, on installing the previous version. Most likely, we're going to need to restart the kernel for it to work. So let me restart here the kernel. We're going to import pandas, matplotlib, seaborn. We're going to import AlanaPy, and we're going to instantiate this data source class from the AlanaPy script into my API underscore ds. We're going to give the kind of AlanaPy, we're going to give the Alana token as such. And we're going to declare the project we're working on. Currently, we're on the open project. We are going to run this command that will give us the ability to create a master instantiation of this class on the myAPI underscore ds with the token that we gave and the root URL that we're working on the project. And if everything works fine, we're going to get the connection established successfully. And in order to test it, we can call a very simple script of that function, and we're going to get the response back from the server. What happened? There we go. In this case, I used the function getFieldsWellsDict, and this gives you the dictionary, and if we go into the key bold field, we're going to get the wells that are stored in this kind of this dictionary. Okay, I'm not going to use in this case both, but what happens if we want to test or if we want to see what fields are on the database? Well, that's pretty simple. We call the instantiation myAPI ds. We can access the master the master field master dict, and if we run it, we execute this command, we see that we have currently on the database both. We have field A, we have field B, and we have the Loma Campana field. In this case, this Loma Campana field we talked about on the section of the Argentina, uploading the Argentina database to Alana. We're going to use this Loma Campana field to develop this well status workflow. So we're going to call Loma Campana, and we're going to get all the wells that are that correspond with this field. I don't want to see them all here, so I'm going to using some indexing kind of form. We're going to see the first 10. This goes before, and we have the first 10 elements of this list, and so on. Okay. We in previous sessions, we checked that let's do that. Let's go step by step. If we call from the instance my API underscore VS, we get all the function that start with the get word. We are going to see that we have the get well status functions here. If we check its docstring, it says function that fetch the well status data of a given well name, and if empty, well name all database. We can see the arguments are string the well name, it's predefined or it's preset as none. And we're going to have these arguments, and we're going to get in response a list of dictionaries with ID, status, reasons, ALS. If we, for example, let's call just one well, we are going to use this list, and I don't know, maybe the 12, the 200 indexed well, we can see that this well has this well FK, this foreign key, or this well ID. Its status is producing. The reason it's effective production, and the type is it's a well type or a production well type. We have the artificial lift system as natural flow. Let's call, I don't know, the 150. It says once again, natural flow, production, effective production, and producing. Let me see if I can get maybe a this is an empty well, doesn't have any information. So 150 maybe. Producing natural flow, no. Okay, so maybe that's not the best way to see things. What happens if we leave these arguments empty? Well, we're going to call all the database from Alana in this structure that we saw on the docstring, a list of dictionaries. This we can change into a pandas data frame structure using the simple commands, and we're going to get the data frame form of this response from the Alana server. We're going to store this into a data frame called data frame well status. But we have a little thing here that is the well ID. We would need to get the well names from the database as well in order for us to kind of visualize it in a much more neater way. This is a work in progress. We're still working on the backend to for the backend to respond the data frame, but without the well ID, but having the well name only. So that's still a work in progress. We are working and focusing our efforts there as well. But in order to do that, it's quite simple. We checked in previous sessions that if we created a dictionary, we could use the pandas command of replace to replace any elements of a column with another element. So we placed on the my API on the master, we have, let's see the variables here. We have here the IDs well names. What this gives you on response is it's the ID and the well name in a dictionary form. The key being the ID and the item or the value being the name. So just by using this command df well status, we're going to create a new column called well names equals to df well status. I know that the column that I want to change is well fk dot replace, and we are going to pass on this this dictionary. If we paste it on here on the replace argument, we call it, it's going to execute. And if we print the data frame again, we're going to have the well names column, the correct well name column in this form. Okay, so we can keep doing some things here. Maybe maybe we want to see the values that are inside this data frame. We can use a very simple for call in df well status.columns. We can look for, I want to give me a list of unique elements. It's going to be a list with the well status call. We're going to iterate in columns dot unique. And I don't know, maybe if print let me use this special form of printing strings. Print column call has elements dots. We're going to skip a line, and we're going to print the first I don't know, maybe unique. Maybe let's print the first 50 elements of this list. Let's run it. What happened here? Yes, I forgot to place this. Well, if K has elements, yes, of course, the list uniques. It's this like this. There you go. Let me print a space here for it to be a to see it more clearly. And for example, in this data frame, we have several well IDs. We have a lot of elements here, but in the status column, we only have either shot or producing. That gives you the information of this, if this well is producing or not. The reason of this well being producing or shot, we can see that we have workover, we have effective production, we have a temporarily shot wells as well. We have producing well injecting, shot due high water oil ratio. We have two abandonment wells as well, and pending resolution. In the type column, we have either exploration, production, or service. The artificial lift system, we have without any artificial lift method, we have the plunger lift, natural flow, sucker rod, gas lift, and hydraulic pumping, and all the well names that we have on that stored on the database. In this case, let's see if we're going to do a very simple selection of, I want to see all the wells that are closed and its reasons. So I'm going to create a data frame. Let's remember that in order for us to have a data frame with all the elements that we want, we need first to have like a series of Boolean values. Those Boolean values, we're going to get them from a condition. In this case, we're going to, from the column, it's status. Let's paste it here. If it's equal to shot, this will give us either true or false, a series or true or false. If we store this, or if we call outside the df well status and we run it, we're going to get only the wells that have this condition. So in this case, this data frame shows us only the wells that are in a shot status. And we can see that the reason is this well, this QX1 doesn't have an ALS. It's an exploration type, and currently it's been a workover done to the well. The shot, another shot well, it was a production well. It's temporarily shot. It's a sucker rod artificial lift system, and it's this well. and it's a horizontal well. That's interesting, horizontal well here. We have another well, not production, but this one was a natural flow well, and it's temporarily shot as well. And we have, for example, here, shot due high water roll ratio. It was a three soccer rod wells that are currently shot. That's it. If we, for example, if we call the counts, it was this function counts. I don't remember, but I think that it was dot value counts. In that way, we are going to be able to see the value of each column. Give me just 1 second. Dot value counts for us to see the elements. No, it's no. For this to work, we need to iterate for call in the well status columns. We're going to count all the elements inside that and see how many temporarily shot and so on and so forth. We're going to call here the call column. We're going to run it. Yes, I forgot to add the print because it's an object. For example, here we have the shot. We have 41 values. Temporarily shot, we have 36 values. Shot to high water roll ratio, only we have 4 occurrences. A workover, we have only 1 occurrence. We have 39 production wells being shotted and 2 exploration wells in this data frame. We have 30, we can see that we have 30 wells that has a soccer rod method, and 7 natural flow, and so on and so forth. So this gives us a very good insight. Maybe we can do, instead of calling all the columns, we can create a very simple list of, I want to add reason, to visualize it way better, a much better way. Let's type. Let's the ALS. As we are seeing only shot wells, we are going to be able only to see the wells that we want. Either yes, I'm going to add here new line. There you go. So we have for this column temporarily shot 36, 39, so on, 30 in this ALS methods. Excellent. What else? What else can we do? Well, we can keep filtrates. We can keep sorting this data frame in the way we want for the data to be shown. But we can do as well some very basic and very powerful statistic functions. Using, in this case, I'm going to use the SNS catlot function from Seaborn. I'm going to, I did this, a very simple loop in columns, but if the column, it's a data type object, I don't want to plot neither WellFK or any value, any numerical values. I place this condition. If it's an object, you're going to go here and use the catlot to plot the counts of the columns with this palette and this data frame, and we're going to rotate the tick certain degrees of rotation. So in this case, we have, for example, we have currently a couple of wells here that it's been shotted. A lot of wells that are currently producing more than 600. In workover, we see a very little value here. The effective production, we have more than 600 as well. Temporarily shot, maybe 50, 30, 40. producing while injecting, maybe 10, and we can keep kind of getting data from this data frame. Okay, we have production here, exploration. We have just a couple of wells in exploration method, and the service classification as well. The most common artificial lift method, it's plunger lift. As we can see here, it has approximately 275 wells in plunger lift method. Natural flow goes a couple of 200, and a sucker rod close to 200 as well. And the one that has the least occurrences, it's the hydraulic pumping. The well names, unfortunately, the well names as well, it's a column with an object data type. So that's why we got a count here, but I mean, the count is only one because it has only one well, and that's kind of the unity. So that's why we have this plot. And in order for us to kind of delete it, we would need to kind of get that off from the list that it's plotting. Okay, so what happens if we want to do something else? For example, using the Plotly Express library, and we want to kind of plot the percentage of this well status information that we get from the data frame. So I'm going to use this another very simple for loop. And then again, I'm going to use only the objects, and I'm going to create what we created previously, which is a data frame of counts, that it's going to count all the elements of that column, and it's going to place them as values on the pie plot of Plotly. And we're going to show this figure every time it's going to loop. So if we run it, we're going to get there you go. We are going to get the status 94.2%. It's producing well. It are producing wells. 5.82 are shot. Effective production 89.9%. The workover, we only have the workover. Let me kind of turn off all the values. If we see things between producing while injecting and workover, we can see that workover has 25, only one well. It's in workover situation, and producing while injecting, we have 3 wells in that form. To abandonment, we have 4 wells, and to abandonment, we have 7 wells. And shot it due to high water run ratio, we have 4 wells in all the field, which is a very good metric. We have 634 effective productive wells. If we go to type, we have 694 production wells and 9 exploration wells. We have 2 wells of service. And if we keep going further, we can see that the plunger lift, we have 270, natural flow 240, sucker rod 197, and we can keep developing. We can keep doing things with all the open source, all the tools that Python gives us, that this Jupyter Lab, Jupyter Notebook gives us, and we can keep growing. We can keep building things from scratch, from all these workflows. So regarding the well status database from Alana, this would be its kind of basic workflow. And then again,